16. Again, all of these problems, 9 through 17, we're solving the equations by factoring. So we can make our lives a little bit easier by dividing each side by 2, giving us 3x squared plus 2x equals 0. If we factor out an x, we would get 3x plus 2 equals 0. Setting each factor equal to 0, we get x equals 0 because x is one of the factors. That's an okay thing to do. Subtracting 2 and dividing by 3 gives us x equals negative 2/3. And so we have two solutions to this equation, x equals 0 and x equals negative 2/3. Now for problem number 36, if you have a graphing calculator, you may use it. Let's see if we can get this in there. Oh wow, that's not easy to see. Maybe there's too much light. Hold on a second. Get the light on there. No, that's not doing it either. Oh, that's really dark. Okay, that's much better. So what we're going to do here is we're going to type in negative 16 t squared. I know I don't have a t on my calculator, so we're just going to use x for the t. So the x on the calculator is the t in the problem. And we have this object that says this function gives an object's height in feet at t seconds. What does the constant 1700 tell you about the height of the object? Well, if we don't need the calculator yet, but if we set up a t and an h of t chart, when t is 0, and we would replace t with 0, we would get negative 16 times 0 squared, which is just 0. And so 1700 tells us that for part A, we would say the constant tells you that at time 0, at time t equals 0, the object is 1700 feet high. So maybe 1700 feet is the height of the building or a bridge or something. And what does the coefficient of t squared tell you about the direction the object is moving? Well, that's a really good question. So B, that coefficient of the t squared is negative 16. Since, and let's call that an A. All right, so with every quadratic function we have, let me write it right up here. If we think of a quadratic function in terms of ax squared plus bx plus c, that a value, when it's positive, tells us that we have a parabola that is opening up. When the a is negative, we have a parabola that opens down. So we've talked about that. This is like a face, right? So when we're positive, we're happy. When we're negative, we're unhappy. So if you think of those as faces, it's hard to forget those. So what that tells us is that the direction the object is moving down. In fact, since if you plug in a couple more values for t, like at 1 second, we'd have 1700 minus 16. So what's that? 1684. And then when x is 2, or when t is 2, we have 2 squared. That's 4. 4 times 16 is 64. 1700 minus 64, what's that? 1636. So you can see these numbers, as t gets bigger, these numbers would continue to go towards 0. Okay, as t gets bigger, in fact, that's exactly what happens. If you were to plot the points, you would see that this is and again, we know that this is a parabola. It's the right half of the parabola has a vertex at 0, 1700. So part B, what are we supposed to answer here? What is the coefficient? Oh, it tells us that since A is equal to negative 16, which is negative, the object is moving down. The object is, let's see, descending. It's moving down. The height is getting lower. We could say any of those things. So getting lower, moving down. Okay. So part C, when will the object be 1,000 feet above the ground? Well, we want to know, so part C is asking us h equals what when, oh, nope, we want to know t equals what when h is equal to 1,000. So how do we solve that? Well, we solve that by setting h equal to 1,000 and figuring out what the t value is. So if we add 16t squared to both sides and we subtract 1,000 from both sides, then we would get 700. Now let's see, does 16 go into 700? Let's try. 700 divided by 16, it does not. So better than that, then let's go ahead and graph this function. And I don't know how long it's going to take to get to the ground, but let's try that. And let's make sure our y max is about 1800 so we can see it. So we can see that's what the graph would look like. And it looks like it's going to take a little longer than 15 seconds to get down to the ground, or longer than 10. So that's what the graph would look like if we also graph y equals 1,000. Question is, if we graph that, we would see that red line is the graph of y equals 1,000. The blue curve is our height curve as a function of time. And if we figure out where they intersect, we would see that they intersect when x is about 6.6, let's say 6.6. So when t, so we can use our calculators for this one, t is about 6.6 seconds. So at about the 6.6 second mark, the h is going to be 1,000. Now you might think to yourself, if we were to graph this from negative 15 to 15, we would see a parabola like that. But in the context of the problem, the time has to start at 0. So that's why we're starting the time at 0. So x on the calculator again is time. All right? So we have 6.6 seconds. And then, okay, I guess I'll just finish it up here. So part D, when will the object be 940 feet above the ground? Well, we do the same exact thing. We just change the 1,000 to the 940 and make sure we don't put anything up but that. So 940. And then, well, the red line is y equals 940. And if we figure out where they intersect, you would see that they intersect at let's call it 6.9 seconds. So let's see, 940, is that what we did? Yeah, 940 is equal to negative 16t squared plus 1700 when t is about, use a little squiggly equals, 6.9 seconds. 6.9 seconds. Okay, so we already answered part C over there. And then part E, what's a reasonable domain and range? Well, again, looking at the graph, let's go ahead and look at the graph over here for part E. Part E, the domain would be from 0, times 0, to whatever that time is. So time equals what? That would be the reasonable domain because the object is not going to go under the ground. And so all we would have to do is, let's see here. Let's change that to like a negative 50 so we can see the x-axis there. And again, the x-axis is the t-axis. So the x-axis on our graph, or on the plane here, is the t-axis in time. So if we figure out where that parabola hit the x-axis, we can mark it to the left there and then go just to the right and then back it up a little bit, and we can see that at about a little after 10 seconds, so like at the 10.3 second mark, the coordinates of that point would be about 10.3 comma 0. So think about it. When t is 10.3, the object hits the ground. So that's a reasonable end of the domain, right? So the domain then would be between 0 and about 10.3. And a reasonable range, the lowest y, would be 0 for the height, and all the way up to 1700. So 1700 is the maximum height. That would be a reasonable range.